Okay, this video tutorial is going to be a little bit of an introduction to alkenes. So alkenes are also a homologous series of hydrocarbons, so molecules that contain hydrogen and carbon, or organic compounds. And the thing is, they essentially contain a double bond, or a double covalent bond, between two of the carbon atoms. And they, just like our pattern before, they always end with the suffix "ene", E-N-E. So alkanes, as the name suggests, end with "ane", A-N-E, and alkenes always end with E-N-E, so alkene. So for instance, what would the name of this molecule be? Well, we've got two carbons, so two carbons, remember, we use our chemical counting system. So 2 is eth, and because it's an alkene, because it's got a double bond, it's ethene. So this particular alkene is called ethene. So if the carbon had 4 bonds, or if it had a third hydrogen there, it would be ethane. But because it's got this double bond there, it's ethene. So alkenes are a homologous series that contain a double covalent bond between two carbon atoms, and they end with the suffix "ene". Now they have the general formula CnH2n, and we'll talk a little bit more about that at the end. So, alkenes. Alkenes are often are said to be unsaturated. So alkanes, which we looked at previously, are often referred to as saturated because they have the maximum number of hydrogens that can be bonded. So carbon has 4 valence electrons. It likes to form 4 bonds. So that's the maximum number of hydrogens that essentially can be in that molecule. So alkenes are unsaturated because they have double bonds, or they don't have that maximum number of hydrogens. So you can see here, this one has 3, 4, 5, 6, 7, 8 hydrogens. So this is 3 carbons. So we could even write the formula. So this would be C3H8. And essentially what you've always got 2 for each carbon plus 1 on each end, so plus another 2. And that's actually why we say the general formula for alkanes is often we say Cn, so whatever the number of carbons is, then we've got H2n plus 2. So for an alkane, if you've got 3 carbons, it'll be C3 is N, C3, and H2 times N, 6 plus 2 is 8. So that makes sense. You've got 8 here. It's telling us we've got 2 on each carbon plus another 2 on the ends. Whereas alkenes are unsaturated, you'll actually see here, because of the double bond here, this carbon now has 4 bonds because of the double, and this one has 4 because of the double there. You can see the formula actually is now C3. We've still got 3 carbons, but count the number of hydrogens. 1, 2, 3, 4, 5, 6. H6. So we've got 2 less hydrogens, and that makes sense because in an alkane we would have had a hydrogen coming off each one of those there. That double bond would kind of open up, and we'd have a hydrogen just above each of those carbons. So this has slightly less hydrogen. So we say it's unsaturated. It doesn't have as many hydrogens as possible. And that means that the general formula, the generalized formula for an alkene is actually slightly simpler. It's basically Cn, so whatever number of carbons you have, H2n. So that's saying whatever the number of carbons you have, so in this case 3 carbons, you'll have twice the number of hydrogens. So here it's C3H6. So using those generalized formula, you can actually work out, what the formula is for, so if we had an alkane that was 20 carbons long, it would be C20H, 2 times 20 is 40, plus 2, 42. It would be C20H42. If we had an alkene that was 40 carbons long, it would be C20H, 2 times 20, 40. So it would be C20H40. So a chain that was 20 carbons long, an alkene 20 carbons long, would be C20H40. So those are the general formula for your alkanes and alkenes. And alkanes, as I said, are often referred to as saturated, and alkenes as unsaturated because of that. Alright, so what relevance does it have on us in real life? Well, these are examples of fatty acids. They're part of a fat molecule. And if you eat foods that contain animal fats, they are often what we call saturated. So they're more just in a straight chain like this. Whereas you may have heard of unsaturated fats are ones that have double bonds. And these unsaturated fats are slightly easier to break down and tend more often to be liquid at room temperature because this kink prevents the molecules from packing together as nicely, lying right next to each other, so it reduces the intermolecular bonds. They're more likely to be liquid. And that explains why a lot of plant fats are oils, are liquids, whereas animal fats are solids. And so unsaturated fats are supposed to be a lot better for you. So if you ever wonder what we mean when we say unsaturated fats, this is just part of the fat molecule, but there's a chain and there's a double bond in that chain, makes it unsaturated. So saturated versus unsaturated. You can also have polyunsaturated fatty acids, or again, this is part of essentially a fat molecule, where there's lots of double bonds, and those are supposed to be even better for you. So why is there no such thing as methane? It's a good question. Well, what is methane? Think of methane as carbon with 4 hydrogens. There's no such thing as methane because there's no other carbon to double bond with. And hydrogen, remember, hydrogen has 1 valence electron, and it will share 1 electron with the carbon, and those two give it a full outer shell. So it's not going to want to share anymore. So hydrogen, as a general rule, doesn't form a double bond because it only needs to share 1 more electron to gain a full outer shell. So you don't get any double bonds if you've only got 1 carbon atom. You really need double bond. Those double bonds really only occur between between say carbon-carbon atoms, or maybe carbon-oxygen atoms. So there's no such thing as methane because it's only 1 carbon, and hydrogen only needs to share 1 electron. So a pair here is already enough for hydrogen to have a full outer shell. So you won't get double bonds with hydrogen. Cool, so properties of alkenes. I thought I'd throw this in. We're not going to do that as a separate video because basically they're very similar to alkanes. Alkenes are slightly more reactive, and again that's because of that double bond. So alkenes will often react. If we look at ethene, the double bond here. Sorry, terrible drawing, I know. But ethene, sometimes this double bond will react, it will actually open up, so it will sort of almost split in two, and it will become, for instance, an alkane or some other type of organic compound. That double bond will open up, and something else will bond. So we could add another hydrogen here and a hydrogen here. So for instance, if you react ethene, the one with a double bond there, with hydrogen gas, that double bond will open up and you'll get it bonding with hydrogen. So it is slightly more stable, or it's energetically favourable for it to have 4 single bonds rather than that double bond. So if it can react with something, that double bond sometimes will open up, and it will then share electrons with the hydrogens or with oxygen or other atoms here if they're available. So they're slightly more reactive, and those molecules with triple bonds, they're actually called alkynes, Y-N-E, are even more reactive. So double and triple bonds are a little bit less stable in that respect, or make them make the molecule more reactive. Alkenes are insoluble in water. That's actually true for alkanes too. So alkanes and alkenes don't dissolve in water. So if you mix them with water, you'll have a separate layer floating, just like oils or fats. Or candle wax is often a bunch of very long chain alkanes, and even liquid wax will sort of float or stay separate, won't mix with water. And again, the boiling points and melting points too increase with their size. So that same trend, as they get longer, they have higher melting and boiling points. So they basically follow the same trends as alkanes. Longer molecules, higher boiling and melting points, insoluble in water. The only difference is that alkenes are slightly more reactive, is really the key point of difference. So lastly, just alkanes versus alkenes. As we said, not a great deal of difference. Alkenes slightly more reactive. So alkenes here, more reactive. More reactive. We've got the double bond. I'll just draw it like that to be quick. Alkanes are saturated. Are often referred to as saturated because they're completely surrounded by hydrogen. So we could put on this side unsaturated. And just coming back, remember that generalized formula. An alkane always has whatever number of carbons it has. So Cn, N for number. It will have H2N, twice as many hydrogens, plus an extra 2 hydrogens. So that's because every carbon in the chain will have a hydrogen on above and below it, but you've also got the extra 2, one on each end. Whereas alkenes have Cn, whatever number of carbons they will have twice the number of hydrogens. So they always have 2 less hydrogens. They don't have that plus 2 less hydrogens in each molecule of alkenes. Yeah, those I guess are the key differences between alkanes and alkenes, and I think that's really it for alkenes at this stage. So we'll leave it there, and we'll try and get on with the next video. Cheers.